We're going to talk about polynomial inequalities today. So when you're given a polynomial function, the polynomial inequality has the general form of f of x is greater than 0, greater than or equal to 0, not equal to 0, less than 0, less than or equal to 0. So the inequality f of x greater than 0 is true when f of x is positive, and that makes sense. Any number that is positive will always be bigger than 0. The inequality f of x is less than 0 is true when f of x is negative, and that makes sense. Any number, negative number is always going to be less than 0. So what we're going to do, or what we are tasked to do in chapter 2, is that, or in this section, we are asked to solve polynomial inequalities. So first you want to move all the items to one side of the inequality so that 0 is on the other. You're going to completely factor the polynomial and find the zeros. Plot the zeros on a number line. Then we will choose test points for the interval. And then we will write our solution in interval notation and use parentheses or brackets where necessary. So in the first particular problem, our problem is already set to 0, so we don't have to worry about doing that. So I am going to go ahead and factor that. So the factors are x plus 6 and x minus 1 when you factor that quadratic. Then I'm going to take each factor, set it equal to 0, and solve it. So I get a key value of negative 6, and I get a key value of positive 1. All right, so what I'm going to do is I am going to put open circles on negative 6. And then I'm going to put an open circle on 1 because of that inequality circle or symbol. So in the second one, I'm going to change it a little bit. We're going to put a equals to symbol so you can see the difference between the two. So now I did step number 1. I moved all the terms to one side so that the inequality has 0 on 1. I completely factored it. I found the zeros, which are negative 6 and 1. I plotted those zeros on a number line with the appropriate open circle versus solid circle, and I'll show you the solid circle ones in example 2. So now we're to step 3, where we choose a test point in each interval. So what we are going to have to do is, in each interval, I'm going to choose a point. So I'm going to choose negative 7, which is to the left of negative 6. I'm going to choose 0, which is between negative 6 and 1. And then I'm just going to choose 2, which is between or to the right of that other key value. So what I'm going to do is I'm going to plug each one of those numbers into the original problem. So I'm going to erase this to make room. If you need to pause the video to copy any of that I just erased, please do that. So the first test point is I'm going to plug in negative 7. When I do that, I'm going to plug it into the original problem. Or you can plug it into the factored version, which was x plus 6, x minus 1. So that's going to be negative 7 plus 6, negative 7 minus 1, and that is negative 6 times negative 8. That is going to be a positive outcome, so that works. So that means this section works. Any number over here to the left of negative 6 will work. When I try to plug in 0, not negative 7, we've already done negative 7. When I try to plug in 0, I'm trying to get that to erase. When I plug in 0, I have 0 plus 6 and 0 minus 1, which is less than 0. That's 6 times negative 1, which is not greater than 0. So I cannot shade anything between negative 6 and 1 because the value, the test point that I chose, did not work. So now I'm going to do my last test point, which is over here in this area. So I'm going to try 2. So that's 2 plus 6 times 2 minus 1, which is greater than 0. So that's 8 times 1, and 8 times 1 is indeed greater than 0. So I can shade all of these numbers. So my solution would be negative infinity to negative 7, parentheses, because we have an open circle, negative 6. We have an open circle on that key value, negative 6. Then I'm going to pick back up with 1 and go to infinity. So for problem number 2, we're going to isolate, or we're going to put 0 on one side, which it already is, so we don't have to worry about that. I need to factor it. And when you factor this quadratic, you get 2x plus 5 and x minus 3, which gives you the two solutions of negative 5/3 and x equals to positive 3. So what I'm going to do here is I'm going to mark both of those on my number line. So I am going to put, since I put that or equals to symbol right there, I'm going to put a closed dot on 3. And then at negative 5/3, which is between negative 1 and negative 2. So we're just going to kind of estimate, between negative 1 and negative 2. Just kind of estimate where that point is. And I'm sorry that it's really kind of hard to see. And so what I'm going to do is I'm going to check negative 4, I'm going to check 0, and I'm going to check 5. So when I plug those numbers in, when I plug negative 4 in, that gives me negative 8 plus 5 times negative 4 minus 3, and that should be less than 0. Well, a negative 3 times a negative 7 is a positive number, and no positives are less than 0. So negative 4 doesn't work, which means I cannot shade anything on that side of the line. I'm going to test 0 next. 2 times 0 is 0 plus 5, and then I get 0 minus 3, and that should be less than 0. A positive 5 times a negative 3 will indeed be less than 0, so that means I can shade everything between my negative 5/3 and my 3. And then the last number I'm going to check is my 5. So I'm going to take 5, plug that in, so that's 2 times 5, which is 10, plus 5, 5 minus 3. That outcome should be less than 0. Well, I get 15 times 2, which is not less than 0. So I can't shade anything on that side. So I only get the little chunk of numbers in between my two key values. So my answer, including brackets, because of this symbol requiring solid circles, would be, or solid dots, would be negative 5/3 to positive 3. I can only use the numbers between those two based on all the work that we did, marking our zeros, and then taking a test point on each side of those zeros. So if you have any questions about solving polynomial inequalities, please let me know.